let me know once you see it.
Okay, sir.
I might just better now, right?
Yes.
So what do you see on the screen right now? Do you see our PPT?
Yes, sir.
Cool. So embedded systems. You know what embedded system is, right? So it's an electronic product contains microprocessor, okay, software to perform some constituent function within large entity. And then we have some examples. Then we studied the applications and the based on the common types. So first is like functional requirement, and second is microcontroller performance. In functional requirement, we have standalone, real time, network, and mobile. And in real time, we have soft and hard. You know all this, right? So uh, these are mostly self-explanatory. So standalone is like basically standalone. Then real time, which has hard and soft. Soft real time में हमें चलता है. I mean, थोड़ा बहुत delay is okay, but hard real time, no delay is tolerable. Then network is something which is connected to each, the other system to exchange some sort of data, and mobile is something that we can carry. Hey, can you admit the other guys joining in?
Done, sir.
Just a second, just broke here. So, hey Shubham, so we're just going through what we did yesterday, and then I'll start with today's topic. Hey, Shubham is gone. I took his name and he's gone. Anyways, so reshare. Hi Shubham, can you talk to rest of the people and see if they are joining, because we are going to cover really important topics for the day. So if you could get in touch with rest of the people, that would be great.
Okay, sir.
Yeah, please. Yeah. So then types देखे थे हमने सारे. Then microcontroller performance के पे based है small scale, mid scale and large scale, like sophisticated. Small scale में 8 bit controllers use होंगे. Okay. इधर medium में 8 और mostly 16 or 32 bits use होएगा, ये नहीं होगा. And either be similar sort of stuff will happen. Then you studied components like what are timer counters, then interrupt, then program memory, data memory, processor, parallel ports, serial ports, everything we studied in detail yesterday again. Now, what we are, then we studied processor and controller the difference, okay? Uh, RTOS, you guys know, will cover in later units as well. Now we are going to look at architecture of 8051, okay? So this is a basically, very basic uh, microcontroller, okay, to start with. So I've just taken this one as an example. This architecture will give you a very clear idea what exactly is there inside of a microcontroller and how it exactly works. So, what can you see on my screen right now?
It's that the architecture and you have written basic.
Okay, I can write it, right? I mean, you can see whatever I'm writing. That's all right. I wanted to understand. Thanks for confirming. So, this is the architecture. Let me now share my whiteboard. Do you see my whiteboard now? Whiteboard दिख रहा है क्या अभी?
Yes, now it is visible. Right.
Okay, thanks for confirming. So, uh, this is what is this? This is architecture. Okay, architecture of 8051. So 8051 is a general purpose, microcontroller. Okay, it has two timers and counters. Okay, it has 128 bytes of ROM. Okay, and 2 KB of RAM. Okay. Mhm. How does this sound to you? कैसे लग रही है memory and RAM? Will you use mobile phone with this much of RAM? Is it possible?
No, sir, it's too big and too slow to operate.
Yeah, it's just too big. So, but I told it had. I'm just listing down some specifications for you guys. Okay, so it has 128 bytes of RAM, 2 KB of RAM, two timers, two counters. Okay, four input output ports. Okay, these are general purpose input output port. Then there is one like serial transmitter and serial receiving pin, okay, available for serial communication and serial transmission of the data. Okay, there are serial ports as you can see. Okay, then we have one benefit over here that there is on chip RAM, on chip ROM. Okay, then we have two interrupts. Okay, two interrupts. These are the you know features or specification I can say of 8051 microcontroller. And now what we'll do is we'll have a look at it, and we'll have a look at architecture in detail and how it exactly works. So first of all, CPU. So you did not ask me one question. You were supposed to actually. I've been talking about processors a lot, right, during last few lectures. You've been asking me how much is the capability of this processor, like what specification for this CPU in the controller. This is the inside of the controller, right?
Yes,
So
sir.
this is 8-bit, okay? This is 8-bit microcontroller. Understand this thing. This is 8-bit microcontroller, very basic, but does a lot of tasks single-handedly. Okay, so so this 8-bit CPU is there inside of our microcontroller, and how it is operating. So do you remember in last to last lecture we had a discussion about clock cycle. You remember?
Clock cycle, like, no, sir, don't.
Clock cycle, you don't remember. Okay. So, so basically, this is a digital circuit, right? Processor is a digital circuit. So how this digital circuit works? It works on certain sort of signal, okay, which is called as clock signal, okay. So this clock signal is 1010 ka square wave, you can say. Hmm. So that is fed to this CPU, okay, with the help of this oscillator. Hmm. Now, since you guys are not from electronics, I will give you a little background of how it works. So you can see there is a piezoelectric, crystal over here. Okay, this crystal is generating vibrations at a constant frequency. Okay, constant resonant frequency. So this circuitry is done such a way that there are two pins in the controller. Okay, in between those two pins. Okay, suppose this is our controller. These are those pins. You see these two things. This is how it will look in the circuit diagram. Basically, two capacitors of a minimum 30 picofarad, and then we ground it here like this. So this is how this crystal is connected. Now I'll tell you how this crystal is generating, constant frequency, and why do we need this oscillator in place. Okay. So what happens is that this crystal could be any crystal, okay, any natural crystal like quartz, okay. So these crystals have property, and the effect is called piezoelectric effect. So when electrical signal is provided to the crystal, it gives mechanical vibrations, okay. And conversely, those mechanical vibrations are again used to generate electrical frequency out of it, okay. So what is happening is we are getting some sort of electric frequency, okay, out of these, pins of the microcontroller, and which we are going to convert in what? A constant clock cycle, okay. So here inside of the controller, what we have is output of this crystal, right, which is a frequency, constant frequency. But this needs to be converted into a proper clock cycle. How will we be able to do that? With the help of this oscillator part. So this I'm going to draw over here. So this oscillator comes into play over here, okay. Then inside of the controller, this oscillator circuit is there, and output of which is this clock cycle, which is fed to CPU. Okay, CPU operates on this clock cycle in order to process. And what I had told you that if there is one clock cycle and I'm saying my CPU is 8-bit CPU, 8-bit microcontroller means I have 8-bit CPU, and that 8 bits are being processed in this one clock cycle. Do you understand now why there is crystal in picture, why there is oscillator in picture? Kunal, Shubham, you there?
Yes, sir.
So did you understand this? Why crystal is there? Why oscillator is there? Yes or no? If no, I'll explain again. Big deal. Did you understand this?
Yes, sir.
Okay, so a crystal is there to generate a frequency, okay, and we have to convert it into clock cycle, and that's why we have oscillator circuit in place, which is embedded inside of the chip, okay. You don't have to do it externally, okay. External things is only this, the crystal part, okay. This thing we connect externally. This is how it is actually, more specific. So yeah, uh, understood. So now we'll move on to a further part. So now our CPU has constant clock cycle, okay, and it is able to process 8-bit per clock cycle because the capability of processor is 8-bit. Our processor is 8-bit processor, right? Now what next? What all are the things inside of this little controller that we are gonna have look at? Okay, so here is something that you can say bus control. So what is this bus control? What is this bus? Okay, now we'll see that. Let me first get rid of whatever is there on the screen. Sure. Anyway, so let's talk about bus controls. Okay, so what is this bus control? Can you admit somebody joining? Let me know if they have joined. So bus control. अभी controller में we have memory, we have storage, okay, we have uh, data flowing from one end to other end, from CPU to the end port, and vice versa. So it's exchange of data that is happening, and exchange of addresses that is happening, right? So what exactly is happening here and how exactly it happens? It happens with the help of bus control, okay. So do you see on chip ROM for program code, okay. So ROM for program code, what do I mean by this? Is this data memory or program memory? ROM is, can anyone tell? I had asked yesterday also. Anyone? Tell me which is program memory, which is data memory.
ROM is process and RAM is data.
Program. Okay. RAM is data memory. Okay. And ROM is program memory. So we have on-chip ROM, means on-chip program memory in place. We have on-chip data memory in place. So this is memory by the word itself, you know. So memory will have some locations, right, to which data is to be stored, right? How will controller know where data is to be stored? How will everything happen? It is happening with the help of bus control, okay. So what this bus control is doing is that it takes over the control of data bus and address bus. Data and address buses are there. Data bus, of course, the name suggests data flows in it, okay. एड्रेस बस में क्या होएगा? एड्रेस फ्लो करेंगे, ठीक है. Addressing in microcontroller is 16-bit, okay. Address of the memory location is 16 bits. It depends on memory size as well, okay. So what happens is that the 16-bit address is being addressed, being flown by the address bus, and that is controlled by bus controller. Okay, that is the point I'm trying to make. So this bus control, we can take over this control as well. Okay, how we can do that? With the help of coding. Okay, we are going to learn in future session how this controller is coded. First, we'll go for assembly level coding. We'll learn the instruction set, and to write a code in assembly language, basically, you need to know hardware well for it. Okay, that's why we are learning hardware part as well. So this is about on-chip ROM and the bus control. Okay, if you see the diagram carefully, everything everything is interconnected, right? The link is established everywhere. Okay, and at the end, it is getting connected to where the CPU. Okay, because that is where everything is happening. Now this ROM, what is exactly stored in the ROM? Our code. Okay, our code is sitting over here. Like, okay, this is our data memory. Then we have timer and interrupt controllers. Okay, T0, T1. Okay, these are counter inputs. Now, what do I mean by counter and what do I mean by timer? So, any guesses, guys? Wild guess? Anything? Anyone want a wild guess? Timer and counter difference? Anyone? Any wild guess? Okay, no issues. So, timer, counter. So, what happens is that when I say timer and when I say counter, one thing that changes is that counter is counting the number of events happening. Okay, timer is a particular period of time set for what an event to occur. Okay, we can say wait for this much of time and then trigger this signal. Okay, this is timer. Or we can do one thing, we can accept the input from our T1 port or T1 pin of a controller, and we can say count the number of events happening and then trigger this particular event. Now, are you understanding difference here? Timer is time basically. Timer, okay. It is just timer, normal timer. Counter is counting the things. Timer is when we say wait for this particular time and then trigger this. Counter is count these many number of events happening, and once the desired number is achieved, then trigger this event. So this is basic difference between the two. Okay, so how it works basically. So timer, as you know, it is nothing but inbuilt feature provided by our microcontroller. So timer काम कैसे करता है? So as I told you, we have an oscillator which is generating a constant clock cycle for our CPU. Okay, so similar clock cycle is used for timer also to calculate the time interval. Now you know that this particular clock cycle is function of time with some constant frequency, right? And do you know relation between time and frequency? Anyone? Did you know this relation before? So time is function of frequency, or frequency is function of time, we can say. So what happens is that this is how, the point I'm trying to make here is that this is how it is counted basically. The time is counted with the help of frequency. Now let's say you want some, different sort of frequency to calculate the time. I will tell you later about how to generate square wave at the output port of the controller using of particular frequency and how to do that. So for that we have T0 and T1 pins. Okay, T0 and T1. Now what is this T0 and T1 thing? Okay, so T0 and T1. So T1 T0 जो पिन होती है माइक्रो कंट्रोलर में, उससे हम क्या करेंगे, इस पिन से हम एक्सेप्ट करेंगे एक्सटर्नल एक्सटर्नल क्लॉक, अगर हमें टाइमर के लिए कुछ चाहिए तो। एंड T1 से हम क्या करेंगे, इट इज a counter basically. Okay, एक्सटर्नल इनपुट्स हम काउंट करेंगे इस पिन से, इस पिन को कनेक्ट करके. सो दिस इज काउंटर एंड दिस इज external clock signal. So this T0 T1. Okay, and serial port TXD RXD. this is this is a pin. Okay, this is a pin in this particular microcontroller for serial transmission of data, serial transmission. Okay, and this is serial receiving, serial reception of the data. So this is how it is working all together. When put together, it becomes a controller, and all the parts work in conjunction to serve a purpose which we know already. So this is, I guess we did talk about, okay, we did not talk about interrupts, int 0 and int 1. It has two interrupts, right? I'll talk about those interrupts now. So interrupts in microcontroller is nothing but two number pins. Okay, two pins in our 40 pin का package क्यों provide किया गया interrupt to know, to sense the event that is happening from external or internal site, and then trigger an interrupt service routine out of it. So how, what do you mean by interrupt service routine? So हमने ये last lecture में भी पढ़ा था what is interrupt, but I'll explain you again. So interrupt is basically, suppose मेरी एक system है, ठीक है, and that system is counting something from external. Then I can say once this particular count is reached, do these activities, ABC activities, okay, whatever those activities are. Until that count is not reached, you can continue the rest of the code. Okay, मतलब सपोज तुम्हारा एक गार्डन है, ठीक है, जो गार्डन तुम कंट्रोल कर रहे हो उस कंट्रोलर से, गार्डन का कंट्रोल चल रहा है इस कंट्रोलर से. सपोज हमें शाम के 6 बजे गेट ओपन करना है. गेट ओपन करने के बाद हमें बाकी के एक्टिविटीज मॉनिटर करनी है. ओके, देन अगेन भी मतलब ये टाइम बेस्ड है सर. सो 8 बजे हमें क्या चाहिए, सारे पानी के टैंक्स भरने हैं, तो मोटर्स ऑन होनी चाहिए विच आर कनेक्टेड टू सम अदर पोर्ट्स. So that is achievable with the help of RTC, real time clock. But how will it understand this has happened? It will understand with the help of ISR, which is called interrupt service routine. So what happens is that once a particular event has occurred, it understands that I need to jump to interrupt service routine now, complete that task, and then continue with the rest of the stuff. Okay, this is interrupt. So basically, I'm doing my task, somebody is interrupting me. Then I'll attend that person and they'll again continue my task, right? It is similar. आ गया समझ में interrupt क्या है? Guys, you following it? Or you asleep already?
No, sir.
Okay, cool. So interrupt समझ में आ गया interrupt क्या है? So we have two interrupts. So जब हम pin configuration देखेंगे controller का इसी के बाद, then it will be more clear to you. Okay. So we are done with the architecture of our basic microcontroller. Okay. Now what we will do is we will go for pin configuration. We will understand like all 40 pins of microcontroller. Okay. So till okay, it's 8 already. We'll take 5 minutes of break. Okay, and be back. guys back? Are you guys back?
Yes, sir.
Okay, may I see you guys? Like, can you turn your cameras on?
Yes, sir.
Thank you. Kunal, Momita. So the part that I'm going to start with right now is very important, and that's why I want you to be attentive here, okay? And that's the reason I wanted to see you first before we begin with it, so that I know you guys are here with me now. I don't know if you're here, so I need to hear from you guys. Kunal, you there? Momita, are you there?
Yes, sir. Yes, sir. Yes, sir.
Okay. So what do you see on the screen right now? Hey guys, can you hear me? Is my screen visible, guys?
Yes, sir.
Can you be a little quick? Okay, thank you. So, what you see in front of you right now on my screen is pin configuration of 8051. Okay, so this is basically a 40 pin package. Okay, this is called DIP package, which is nothing but dual inline. Okay, you might have seen a lot of processors having this configuration, right? Pins all over the sides, right? So this is also one of the package. Like this is one kind and this is one kind. So there are different types in which the controllers come. The package pin configuration basically. So this is called dual inline. Okay. Now uh, let's let's check out what each pin does. Okay. So this is VCC. VCC means this pin will be connected to constant 5 volt ka supply. Okay, this is VCC and pin number 20 is ground. Okay, so understood these two pins, VCC and ground. So in circuit, this will be connected to supply, power supply, this will be connected to ground. Okay, next we come to our port 0. Now I already told you that our microcontroller is I'm so sorry, not 4 bit, 4. There are 4 ports in our controller. Okay. Hmm. There are total 4 ports in our controller. And how it works is that each port is having its own functional. All 4 ports are bidirectional input output ports. Okay, bidirectional input output ports, but few ports are multi-purpose. Like you see port 3. Port 3 is a multi-purpose port as well as general purpose input output GPIO. Okay, so our port 0 ranges from pin number 39 to pin number 32. Okay, this is bidirectional general purpose input output port. Okay, and it is not internally pulled up. Now what do I mean it is not internally pulled up? We have to use external pull up register to do that. So basically all these pins, okay, all these pins needs a pull up register. Now what do you mean by pull up register? Okay, so we have to connect a register externally and connect it to VCC in order for these pins to be activated. Okay, I will say this is a pull up register. Okay, so this is connected to VCC. Connected elements. So what does pull up register do? So this register is acting a connection between pin and our supply. Okay, this is pull up. Similarly, we'll have pull down register. When pull down, what do I mean by pull down? Pull down is basically same connection. Okay, but you're you're grounding it. Okay, this is pull down register. So remember, our microcontroller is so smart. It is so smart that all the other three ports, that is port 1, 2, and 3, these 1, 2, 3 ports are internally pulled up. Okay, these are internally pulled up. Okay, but this port 0 needs to be pulled up externally by connecting the register. Now you can ask me, what is this AD0 to AD7 then? Okay, I told you about port 0 to port 7. These are general purpose input output pins. Means you can make it input, you can make it output anything. Okay, that is meant by general purpose input output bidirectional. Okay, but what is AD0 and AD7? I told you, right? Our controller is having inbuilt ROM and RAM. Okay, inbuilt, but in some cases 128 bytes of our ROM and 2 KB of our RAM is not enough for successful operation or successful code storage. So what do we do in that case is we connect our controller to external memory. Okay, external memory. So this external memory is connected. So I already told you in architecture, whenever there is a memory, there comes address का location चाहिए बराबर. External memory में हमें कोड स्टोर करना है, राइट? लेकिन किधर स्टोर करेंगे? पता कैसे चलेगा? किस एड्रेस पे स्टोर करेंगे? सो वो जो 16 बिट एड्रेस होता है मेमोरी का, 16 बिट एड्रेस, सो वो जो एड्रेस है उसके लोअर 8 बिट्स, दैट इज 0 to 7, मींस फर्स्ट 8 बिट्स आर हैंडल्ड बाय दिस पोर्ट. अंडरस्टूड?
Yes, sir.
First 8 bits of this external memory ka address are you know multiplexed by these pins, for like these pins of our controller which falls under port 0. Are you understanding now? Are you following up what is port 0 and what are its functions? समझ में आ रहा है ना, ये दिमाग के ऊपर से जा रहा है, मेरे को क्लियरली बताओ।
आ रहा है सर।
आ रहा है समझ में? बताओ मुझे पोर्ट जीरो मतलब तुम्हें समझ, तुम्हारी भाषा में जो भी समझ में आया पोर्ट जीरो के बारे में, कैन यू प्लीज टेल मी सो दैट आई नो द एक्सटेंट ऑफ अंडरस्टैंडिंग। तुम्हें जैसे भी आता है, कैन यू एक्सप्लेन मी व्हाटएवर यू हैव अंडरस्टूड अबाउट पोर्ट जीरो। एनीवन?
So it is the initial starting stage of the service.
मीन्स पोर्ट जीरो रे, सी ये 40 पिन का अपना पैकेज है। दिस इज आवर कंट्रोलर व्हिच इज ऑफ 40 पिन्स, ओके, out of which I explained 39 to 32, okay, 32 to 39 ये 8 पिन का मैंने अभी explanation दिया है, and this pin 40 and pin 20 also I explained, which is on your screen right now. Can you explain me what is pin number 40 doing? Tell me. चालीस नंबर की पिन क्या कर रही है, क्या कनेक्टेड है उधर? लुक एट द स्क्रीन ना, व्हाई आर यू ब्लैंक? स्क्रीन पर देखो क्या दिख रहा है, 40 नंबर पिन के बाहर लिखा क्या है? Just unmute and start talking, guys. Already, I'm not taking exam. We are just trying to have a conversation here. Okay, I'm explaining you. So I want you to be involved equally. Okay, with me. So can you tell me now what is the function of 40 number pin? 40th pin. Look at the screen. It is very clear. Can you see my screen first of all? Is the screen visible?
Yes, sir, it is visible.
Then tell me 40 नंबर के पिन पे क्या कनेक्टेड है?
VCC pull-up register.
Wait, VCC is connected. Okay, VCC is what? Supply voltage for our controller to start working. Okay, pull up register connected नहीं है 40 नंबर के पिन को. Okay, this is just VCC का पिन. Port 0 start होता है. There are 4 ports in our controller. You accept that 4 ports होते हैं, ठीक है? पोर्ट 0 में 8 पिन है, पोर्ट 1 में 8 पिन है, पोर्ट 2 में 8 पिन है, पोर्ट 3 में 8 पिन है, ठीक है? 8 8 8 8. ओके, दिस इज port number 0, and which is from 32 to 39. Okay, 32 to 39. इसमें 8 pins है, and these 8 pins are externally pulled up. Okay, these are not internally pulled up. Pull up is basic, pull up, pull down is nothing but when I say pull up, externally register connect किया है VCC को, pull down means वही register ground को connected किया है, ठीक है? सो ये है पुल अप पुल डाउन का थिंग, उस पर ज्यादा ध्यान नहीं दिया तो भी चलेगा. इंपॉर्टेंट थिंग इज व्हाट इज AD0 एंड AD7. सो आई टोल्ड यू कि हमारे कंट्रोलर में इंटरनली 128 बाइट्स ऑफ रोम एंड 2 KB ऑफ रैम है, बट समटाइम दैट इज नॉट सफिशिएंट. जैसे हम लैपटॉप में भी और रैम एक्सटेंड करते हैं बराबर, कभी कभी हम एक्सटर्नल SSD भी लगाते हैं टू एक्सटेंड द स्टोरेज. तो सिमिलरली इधर हमें ज्यादा स्टोरेज चाहिए, ज्यादा मेमोरी चाहिए, तो विल कनेक्ट सम एक्सटर्नल मेमोरी, राइट? सो इस एक्सटर्नल मेमोरी का एड्रेस कैसे कंट्रोल होगा कि किस लोकेशन पे क्या स्टोर करना है, ये कैसे हैंडल होगा? तो इन पिंस के जरिए हैंडल होगा, AD0 to AD7. ओके, दिस इज मल्टीपर्पज पोर्ट अगेन, port 0, okay, which is general purpose input output port also, and it is also what it is addressing the lower 8 bits of our external memory. Okay, it is multiplexing, those lower 8 bits are multiplexed using these 8 bits. Is it clear now? क्या क्या करता है पोर्ट 0? दो चीजें हैं, जनरल पर्पस इनपुट आउटपुट एंड एक्सटर्नल मेमोरी का लोअर बिट्स. ओके, डायग्राम देखकर ही बता सकते हो तुम यार. AD is address 0 to 7 means what? lower bits of address of what? External memory, right? आ गया समझ में? This is port 0. Now EA, VPP, ALE, PROG, PACN. So ये सारे जो पिंस है ना, ये भी तभी काम में आते हैं जब हम एक्सटर्नल मेमोरी के साथ काम कर रहे हैं, ठीक है? So basically, right side of your microcontroller is all associated with external memory. Okay, so you can see AL is enable access and there is bar. Okay, on top of it, it is written EA and bar. Okay, why is that so? Any wild guesses? वो बार का मतलब क्या पता है ना तुम लोग को? कॉम्प्लीमेंट ये होता है उसका उल्टा कॉम्प्लीमेंट राइट ये बार means it is active low pin. Okay, it is active low pin means when it is grounded it is activated. Okay, and why it is done? Because see, if I have to activate this EA bar, I will simply ground it. It will accept it as an input, that is, and then it is activated. So when EA bar when EA bar is grounded, it is using internal memory. When EA bar is connected to VCC, it is using external memory. Understanding? समझ में आ रहा है?
Yes, sir.
क्या समझे ये बार के बारे में? EA bar is active low. Okay. एक्टिव लो पिन एक्टिव लो मतलब जब इस पे कम इनपुट रहेगा जीरो इनपुट वोल्टेज 0 वोल्ट रहेगा या कम रहेगा देन इट विल बी एक्टिवेटेड दिस पिन ओके एक्टिव लो पिन है ये तो EA इज इनेबल एक्सेस जब हम EA को ग्राउंड करेंगे तो इट यूजेस इंटरनल मेमोरी ओके एंड जब EA को अप करेंगे VCC को कनेक्ट करेंगे इट इज यूजिंग एक्सटर्नल मेमोरी ओके आ गया समझ में एक्टिव लो एक्टिव हाई ओके एक्टिव लो मतलब 0 वोल्ट से एक्टिव होगा एक्टिव हाई मतलब हाइयर वोल्टेज से एक्टिवेट होगा आ गया समझ में आ गया क्या समझ में गाइस ये भी का फंक्शन so active low active high so one thing is that can you you know did you really understand this I mean ये क्वेश्चन तुम लोगों के दिमाग में आया नहीं क्या फिर कि 0 वोल्ट पे एक्टिवेट क्यों करना है आई मीन ग्राउंड पे एक्टिवेट करने का डिसीजन ही क्यों लिया गया राइट when we have our signal with us which can be given to our pin directly why active low means why ground करेंगे मतलब जीरो करके एक्टिवेट क्यों करना है इस पिन को हमें इसका रीजन ये है कि इलेक्ट्रॉनिक्स में हमेशा नॉइजेस रहते हैं इलेक्ट्रिकल जो इलेक्ट्रॉनिक सिग्नल्स जो होते हैं उसमें नॉइज रहता है so any higher signal could be noise also okay so it is easier to detect the dips in the voltage than the ups okay ups could be the noise also but dip है voltage में 0 voltage constant रह रहा है port पे so that is easy to detect right so that is nothing but this act that is why active low is has come into the play okay I don't think you guys are understanding are you understanding guys are you understanding
Yes, sir. Just little bit.
following it little bit at least मुझे रिपीट करने बोलो ना जो भी समझ नहीं आ रहा है तुम बोलते ही नहीं हो until unless I ask you you don't say anything why is that so you should speak up ओके पता हो मुझे समझ नहीं आ रहा है तो रिपीट करना है तो आ रहा है समझ में। आगे बढ़े या ना बढ़े बताओ मुझे। अरे बोलो कुछ तो। Okay, anyways, I'll move ahead. You can go through the recording because you guys are not asking me to repeat it, right? I can't help it. So yeah, uh, EA we are just done with. Then ALE and program bar. So ALE is enable latch. Okay, ALE is enable latch. This is again active low. Okay, active low का मतलब पता है तुम लोगों को? एक्टिव लो मतलब क्या है एनीवन? यस 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 राइट, 0 वोल्ट पे एक्टिव होगा तो सिमिलर एल इज नॉट active low, PROJ is active low, active low. Okay, so enable latch. What is latch means? Latch is sort of a memory only, external memory. So मैंने क्या बताया कि राइट साइड ना ओनली एसोसिएटेड विद एक्सटर्नल मेमोरी, सो इस पे ज्यादा हम मतलब डिटेल में नहीं जा रहे हैं. I'm just letting you know what is function of each pin. Okay, so ALE's enable latch pin, which is when connected to VCC, can enable the latch, which is basically the other memory. Okay, and PROG bar means this programming when programming the external memory, this has to be grounded. Okay, then program storage enable bar. Now when this is also active low, it is also to be grounded if we are using it the external memory. Okay, then we are on the port number 2 now. Okay, ये साइड खत्म कर देते हैं फट से. So port 2 पे क्या है? Port 2 ranges from 21 to 28. 21 to 28 is port 2. Port 2 is also bi-directional general purpose input output port. Okay, which is written. What is written over here? A8 and A15. Okay, A8 to A15. So where is A0 to A7? A0 to A7 is in port 0. A8 to A15 is port 2. Okay, so what does this mean? पोर्ट 0 ने A0 to A7 मतलब पहले 8 बिट हैंडल किए एक्सटर्नल मेमोरी के मेमोरी एड्रेस के. पोर्ट 2 ने बाकी के 8 बिट्स हैंडल किए एक्सटर्नल मेमोरी एड्रेस के. ओके, सो ये दोनों पोर्ट मिलकर एक्सटर्नल मेमोरी का एड्रेसिंग देखते हैं अगर वी आर कनेक्टिंग एक्सटर्नल मेमोरी. आ गया समझ में? पोर्ट 2 इज ओनली फॉर दैट. सो दिस इज अबाउट पोर्ट 0 and port 2, guys. Now we will see the left side, which is port 1 and port 3, which is multi-purpose port, of course. Okay, so port 1, पहले port 1 देखेंगे. ठीक है, port 1 is the simplest port. Okay, it is what? It's a general purpose input output port, internally pulled up. Okay, internally it is pulled up port. मीन्स व्हाट? हियर हमने इधर क्या किया था? एक्सटर्नल पुल अप रजिस्टर कनेक्ट किया था, बराबर. उसको पुल अप करने के लिए हाई वोल्टेज पे. इधर नहीं करना है क्योंकि इंटरनली है पुल अप रजिस्टर ऑलरेडी. ऐसे इंटरनल रजिस्टर रहेगा पिन 1 से डायरेक्टली वीसीसी कनेक्टेड किया है, ठीक है, लाइक दिस। इंटरनली है वो, तुम एक्सटर्नली पुल अप नहीं करना है पोर्ट 0 को। इट इज जनरल पर्पस इंपोर्ट पोर्ट। देन कम्स द रीसेट पिन, ओके। अभी ये रीसेट पिन का फंडा बताता हूँ क्लियरली। रीसेट पिन, तो फंक्शन क्या होगा इसका, नाम से, बस नाम से कोई बताएगा मुझे? कंट्रोलर में रीसेट पिन का फंक्शन क्या रहेगा? एनीवन, कैन एनीवन गेस? रीसेट, गाइस, रीसेट का मतलब क्या है बेसिकली? हेलो गाइस, you there? Are you there in the call?
Yes, sir.
So रीसेट का मतलब क्या? बेसिक मतलब बताओ रीसेट का।
So reset will reset all the it will start from the initial stage.
Beginning, correct. So reset is basically when you hit the button, it will reset the state of all the pins, and it will, what it will do, it will start the controller from beginning, start the program from beginning. So reset का connection बता दो मैं कैसे होता है। So reset को ऐसे ग्राउंड किया है इधर से, and there is a switch connected here, okay, and this is PCC, okay. So अब जब ये रीसेट का बटन दबाएंगे तब क्या होगा, ये जो पावर सप्लाई, रीसेट बटन दबाया तो ये क्लोज हो जाएगा स्विच, करेक्ट, और ये पावर अंदर चली जाएगी, ओके। एक पल्स मिलेगी इसको। As soon as the pulse is sensed, all the status of the pins are reset to initial stage and code is also starting from beginning, okay. जब ये स्विच ओपन रहेगा तब ये बाय डिफॉल्ट ग्राउंडेड है यूजिंग दिस पुल डाउन रजिस्टर। आ गया समझ में? रीसेट आ गया क्या समझ में गाइस?
Yes, sir.
कूल, थैंक यू फॉर कंफर्म। सो ये स्विच जब बंद होगा, ये स्विच जब क्लोज होगा, तब वीसीसी सिग्नल पहुंचेगा पिन पे, एंड एज सून एज इट रीचेस देयर इट गेट्स अ पल्स एंड इट अंडरस्टैंड हमें रीसेट करना है। अभी रीसेट हो गया, हो जाएगा कंट्रोल, ठीक है। दिस इज अबाउट रीसेट। आई विल जस्ट इरेज इट बिकॉज आई वांट टू राइट अदर थिंग्स। I don't have enough space on my whiteboard. I hate this part of this whiteboard. Couldn't they give simple eraser? Okay. चलो, अभी ये जो मल्टीपर्पज पोर्ट है वो देखेंगे हम। आर एक्स टी टी एक्स टी, आर एक्स डी एंड टी एक्स डी मैंने बताया था तुम्हें, सीरियल पोर्ट है ये, ठीक है। सीरियल, सीरियल, दिस इज रिसेप्शन एंड दिस इज सीरियल ट्रांसमिशन, ओके। सो सीरियल डेटा जब ट्रांसमिट एंड रिसीव करना है तो ये दो पिंस यूज होंगे, ठीक है। अभी तुम्हें डिफरेंस पता है ना पैरेलल एंड सीरियल में? हमने बहुत बार डिस्कस किया। कैन एनीवन टेल मी पैरेलल डेटा एंड सीरियल डेटा डिफरेंस?
तो सीरियल में 1 by 1 जाता है डेटा, और पैरेलल में सब एक साथ जाता है।
सब एक साथ, जैसे कि तुमने बाकी के तीन सभी पोर्ट देखे बराबर, पोर्ट 0 1 2 3 सभी पैरेलल, मतलब ये 8 बिट्स एट ए टाइम फीड करेंगे हम, राइट। सीरियल में देखो एक एक ही पिन लगती है। सीरियल रिसेप्शन के लिए एक पिन, ट्रांसमिशन के लिए एक पिन, बात खत्म। गिव मी अ मोमेंट गाइस, जस्ट अ सेक। Sorry. So what I was saying is, सो ये जो है सीरियल आ गए समझ में. नाउ int 0 and int 1. int 0 and int 1. So it is also active low. Okay, interrupt 0 and interrupt 1 is active low. So by default it's connected to what? VCC. When there is interrupt, it will be interrupted. Okay, so interrupt 0 and interrupt 1. So interrupt का basic function समझ में आना. जब इधर signal sense होगा इन pins पे, ओके, जो भी है एक्टिव लो सिग्नल, तभी समझ में आएगा. अगर इंटरप्ट तुमने इनिशियलाइज किया है किसी एक पिन पे, देन आवर कंट्रोलर विल नो कि इंटरप्ट इधर आ गया, इसका मतलब बाकी के सारे काम छोड़ के मुझे पहले इंटरप्ट को हैंडल करना है, प्रायोरिटी उसको देनी है. इंटरप्ट सर्विस रूटीन जो लिखा है वो खत्म करना है, एंड देन गो बैक टू द ओरिजिनल कोड. ओके, मैं इधर बताता हूँ. अगर ये स्टेप, ये तुम्हारा ओरिजिनल कोड चल रहा है, अभी इधर आ जाता है इंटरप्ट. इंटरप्ट आ जाता है तो क्या करोगे, इधर से तुम्हारा कोड जंप किधर करेगा, इंटरप्ट सर्विस रूटीन. ये भी एक कोड लिखा होगा अलग से लाइंस में, ठीक है. इंटरप्ट सर्विस रूटीन पूरा कंप्लीट होने के बाद ये फिर से उस लोकेशन पे जाएगा, मेमोरी लोकेशन पे जहां एग्जीक्यूशन स्टॉप हुआ था, and then it will again continue the execution of the code. Now do you understand what is interrupt? कि एक इवेंट होने के बाद हम कोई टास्क परफॉर्म कर रहे हैं अपार्ट फ्रॉम आवर रेगुलर कोड. ओके, एंड that is called interrupt service routine. Okay, and this interrupt service routine is another code, okay, which executes, and then again our regular execution happens. Okay, this is int 0 int 1, then t0 t1. अब ये timers है, t0 and t1. So I told you microcontroller has internal timers. So what is the requirement of these pins externally, t0 and t1? What do you mean by that? क्यों चाहिए ये pins externally? सो ये सवाल आ सकता है किसी के में कि आई एम सेइंग कि कंट्रोलर में अपने इंटरनल ये है, व्हाट इज द इंटरनल टाइमर्स है, दो टाइमर्स है, तो एक्सटर्नल पिंस क्यों चाहिए? तो मैंने बताया तुम लोगों को कि टाइमर काम किस पे करता है, फ्रीक्वेंसी पे. यू नो, टाइम इज द फंक्शन ऑफ फ्रीक्वेंसी, टाइम इज इनवर्सली प्रोपोर्शनल टू फ्रीक्वेंसी. ओके, t is equal to 1 by f means फ्रीक्वेंसी पे डिपेंड है अपना टाइम, राइट. फ्रीक्वेंसी किधर आ रही है अपने कंट्रोलर में, किधर से आ रही है, इन दो पिन से आ रही है, क्रिस्टल से, मैंने आर्किटेक्चर में बताया था, राइट. सो इट इज टेकिंग दिस फ्रीक्वेंसी फ्रॉम द ऑसिलेटर एंड it is this is how it is counting the time basically. So this is how the time is being counted, but now we are depending on the frequency that is coming inside from the crystal and the crystal which we are using, right. So इस पे हम dependent हो गए, although it is very stable, but for certain computations we need another set of frequency from external source which will be fed by t0 pin. Okay, external clock, एक्सटर्नल तुम्हें क्लॉक चाहिए, क्लॉक साइकिल, तो तुम इस पिन से कनेक्ट करोगे, ठीक है. t0, then what is t1? t1 is a counter, okay, to count external event. Okay, it is counting external events. So it is a counter and it is an external clock cycle. Okay, then what is write bar and read bar? Okay, write bar and read bar. Okay, so write bar जब लो होगा तब तब क्या होगा, एक्सटर्नल मेमोरी का राइट सिग्नल है ये, एंड दिस इज एक्सटर्नल मेमोरी का रीड सिग्नल है. तो ये जब ग्राउंडेड रहेंगे तब ये इनेबल्ड रहेंगे बिकॉज दीज आर एक्टिव लो. So when these are active, we are enabling the write to external memory, and when the RD is low, we are enabling the read operation from external memory. आ गया समझ में? Then we have extal 2 and extal 1. तो इसका तो तुम्हें बताया ही है already. फिर भी हम डिटेल में देखते हैं और एक बार। इधर क्रिस्टल कनेक्टेड होता है, सो ये मैं थोड़ा एक्सटेंड, I'll try to extend these lines outside and then draw. Okay, so xtal1 and xtal2, इसका सर्किट कैसे होता है देखो। इधर क्रिस्टल कनेक्ट होगा, ओके, देन यहाँ पे दो कैपेसिटर्स कनेक्ट करेंगे हम टू हैव इट बैलेंस्ड, एंड दिस सो ऐसे सेटअप बाहर दिखेगा तुम्हें। अंदर क्या रहेगा इसके, इधर बेसिकली एक ऑसिलेटर होगा, ओके, ऑसिलेटर जो हमने आर्किटेक्चर में देखा था, राइट। So that is what will be there inside of it. So this is how it looks externally. And ये जो है ये क्रिस्टल है, ठीक है। It could be any crystal. If I say it is a quartz crystal, so it has a piezoelectric effect. Okay. Now, what piezoelectric effect says is that when an electrical, a crystal naturally resonates at a frequency and generates mechanical vibration whenever it is in contact with electrical signal. Okay. So whenever we give electrical signal to a crystal, it generates mechanical vibration, and like those, conversely, we can convert those mechanical vibration to a constant frequency, and this frequency is fed to these two pins, okay, and these two pins are further connected to a oscillator circuit, and this oscillator is generating this constant clock cycle for our CPU. Understood now? Our 8-bit CPU. सो गाइस, ये पिन कॉन्फ़िगरेशन क्लियर है क्या तुम लोगों को? अगर ये कंट्रोलर समझ में आ गया ना बेसिक, तो सारा बाकी का समझ में आ जाएगा, ठीक है। तो ये
Sir, Excel 1 or 2 और एक बार
Excel 1 and 2, this you are not understanding. ओके ओके, मैं समझाता हूँ फिर से तुमको। जरा कचरा हटाता हूँ पहले मैं इधर से। Let me copy this from PPT, clean diagram. Okay, so एक्सटेल 1 एंड एक्सटेल 2। तो मुझे एक बात बताओ, अपना ये काम कैसे कर रहा है? इसके अंदर सीपीयू पड़ा है, करेक्ट। कंट्रोलर का एक सीपीयू होगा। सीपीयू काम किस पे करेगा? क्लॉक साइकिल पे काम करेगा। आई जस्ट नीड 1 minute guys, my doorbell is ringing. Okay, let me attend it. Okay, give me 2 minutes. Okay, yeah, my house help is here. Okay. Anyway, sorry for keeping you on hold. So my screen is still visible, right?
Yes, sir.
Okay, thank you. So yeah, sorry for that, guys. So Excel 1 and Excel 2 के बारे में डाउट आया है, so let me clarify that. So ये दो पिंस है। अभी I'm giving you relation why we need clock and why need that. Okay, CPU मैंने क्या बताया कि अपना 8 बिट सीपीयू है। 8 बिट मीन्स क्या कि एक क्लॉक साइकिल में 8 बिट्स प्रोसेस होंगे। दिस इज वन क्लॉक साइकिल, ओके, वन क्लॉक साइकिल। सो व्हाट इज दिस, वेयर इज दिस कमिंग फ्रॉम? ये क्लॉक साइकिल आएगी कहाँ से? कहीं से तो देनी पड़ेगी, एक्सटर्नली देनी पड़ेगी, राइट? So it comes from these two pins. Okay. Are you getting a little bit now about it? So एक oscillator से आएगी, ठीक है? Oscillator is an electronic circuit, okay, which generates such signal, okay? Oscillator, ये oscillator मतलब it continuously oscillates and it generates this signal, okay? Oscillate होके ये ऐसे कंटिन्यू सिग्नल जनरेट करता रहेगा एंड इट विल बी फेड टू सीपीयू। अभी इसकी फ्रीक्वेंसी कैसे डिटरमिन होगी? कौन सी फ्रीक्वेंसी पे ये ऑसिलेट होगा, कौन सी फ्रीक्वेंसी पे इसको वेव मिलेगी? तो ये डिसाइड होता है क्रिस्टल से, ठीक है, विच इज कनेक्टेड टू हियर। सो इधर का सर्किट बाहर से ऐसे दिखेगा, ओके, दिस इज एक्सटर्नल, ओके। व्हाट इज इंटरनल? इंटरनल इज ओनली ऑसिलेटर। एक्सटर्नली हम इधर क्रिस्टल कनेक्ट करेंगे, ठीक है, and that is connected with help of two capacitors. ये एक्सटर्नल सर्किट रहेगा इसका, ओके। These are almost 30 or 33 picofarad, I guess. I'll confirm later, but yeah, mostly. And this is our crystal, okay, which I guess it has 30 megahertz of frequency. Now this crystal मतलब होता क्या है मैं बताता हूँ basically. It is a naturally found device, or it is a crystal basically, which uh, which has piezoelectric effect, okay. So what is piezoelectric effect? So when electrical signal is given, it gives mechanical vibrations, okay. And conversely, when mechanical vibrations are there, electrical frequency can be derived out of it, okay. So what happens here is that uh, we are giving electrical signal, we have the mechanical vibrations, so it has its natural resonant frequency at which it resonates and generate that frequency at the output, and this frequency is fed to external 2 and external 1 pin, and internally external 2 and external 1 is connected to an oscillator which is generating this clock cycle for us, okay, which is fed to our CPU, okay. Are you understanding this now?
Yes, sir.
Okay, okay. Thank you for confirmation. So it is that basically, okay. It is generating the clock cycle for our CPU, okay. Are you following up till here? Any doubt anybody else is having?
No, sir.
Okay, so can I assume you understood everything from today's session? At least 70-80%.
Yes, sir.
Okay, thank you. So let me quickly go back and revise. Okay, we'll revise whatever we have done in today's session. Okay, so that you don't miss out on anything. Now you tell me, what do you see on my screen? We have only seen these 2 points today. One is architecture and other is pin configuration. What do you see on my screen right now? What is there on my screen? Architecture or pin diagram? What is it?
Architecture.
Yeah, thanks for confirmation. So this is the architecture of our 8051 microcontroller. Okay, this is a basic architecture. Okay, हर कंट्रोलर का यही चीज रहेगा, बस अकॉर्डिंग टू द स्पेसिफिकेशंस इधर उधर दो तीन चेंजेस होंगे. ठीक है, तो this is this is our CPU. Okay, CPU needs clock signal which we are getting from this crystal and oscillator circuitry. Okay, I just explained you. So this is extal 1 and extal 2. Are you getting it now? Extal 1 and extal 2. Okay. Then our CPU is connected to everything else in the picture. Okay. Everything else is connected to the CPU like this using buses. There are data buses, there are address buses. Okay. Inside of our controller. Okay. And what are the rest of the components? There is interrupt controller which is handling the interrupts when interrupt service routine is written. Then we have on chip ROM and on chip RAM. Okay, this is our what is ROM and what is RAM. RAM is data memory. Okay, ROM is program memory. Okay, देन टाइमर जीरो टाइमर वन वे ये भी पिंस में दिख गया तुमको, मतलब अभी रिलेट कर पा रहे हो ना तुम आर्किटेक्चर क्या है एंड पिन क्या था, तो ये सब चीजें है इधर. ठीक है, तो ETC is event timer and counter. Okay, it is nothing but event timer and counter, which is timer and counter. ठीक है, T0 में क्या करेंगे हम, एक्सटर्नल क्लॉक सिग्नल चाहिए तो T0 पे एक्सेप्ट करेंगे. टी T1 में क्या करेंगे, T1 is for counter. Okay, for counting the events. Serial ports TXD RXD भी देख लिया हमने. ठीक है, 4 इनपुट आउटपुट पोर्ट्स है बाय डायरेक्शनल. ओके, बाय डायरेक्शनल general purpose input output ports. Okay, and the address and data lines are there. Then there is bus control. Okay, bus control is what I told you na, data and address flows continuously here. So who is controlling that? Bus control. This bus control should be in place, right? This is nothing but the architecture. We moved on to the pin configuration. Then I'll quickly revise each pin in the controller. Okay, stop me whenever you have doubt. See, VCC is connected to power supply, ground is connected to ground. Then we have port 0, which is having AD0 to AD7, means it is related to external memory. Okay, एक्सटर्नल मेमोरी का एड्रेस के लोअर 8 बिट्स ये एड्रेस करेगा. एड्रेस इज ऑलवेज 16 बिट. ओके, एड्रेस इज ऑलवेज 16 बिट. सो पहले 8 बिट्स इधर है, बाकी के 8 बिट्स इधर है. ठीक है, देन दिस इज बाय डायरेक्शनल जनरल पर्पस इनपुट आउटपुट and this has to be pulled up externally. External pull up करना है मतलब external एक रजिस्टर पुल अप रजिस्टर कनेक्ट करके VCC कनेक्ट करना पड़ेगा इसको, अगर इसको एक्टिवेट करना है. ओके, then we have EA and VPP. EA is enable access. Okay, enable access, and it is bar. Okay, enable access bar means it is active low. So when EA is grounded, we are using internal memory. When EA is connected to VCC, we are telling our microcontroller to access the external memory. Okay, then alien program is enable latch. Okay, AL is enable latch. So latch क्या होता है, ऐसे समझो कि एक्सटर्नल मेमोरी है उसका एक पार्ट है लैच, तो उसको इनेबल करने वाली ये पिन है. ठीक है, देन प्रोग्राम स्टोरेज इनेबल, एक्सटर्नल मेमोरी में प्रोग्राम स्टोर करते टाइम इस पिन का यूज होता है. Then we came to port 2. Port 2 is also general purpose input output bidirectional port. Okay, bidirectional port. It is having A8 to A15. Okay, इधर क्या है A0 to A7, इधर A8 to A15, मतलब टोटल हो गए पूरे इधर 8 बिट्स एंड इधर 8 बिट्स. टोटल हो गए 16 बिट्स एड्रेस ऑफ एक्सटर्नल मेमोरी. सो address of external memory is handled this way. Okay, now let's come to port 1. Okay, port 1 is again bi-directional general purpose input output port, which is internally pulled up. Okay, internally pulled up. Okay, देन रीसेट का भी मैंने ड्रॉ करके बताया सर्किट तुम लोगों को. वीसीसी है, एक स्विच है, ओके, एंड ग्राउंड किया है. नॉर्मल इट इज ग्राउंडेड. व्हेन स्विच इज क्लोज्ड उसको सप्लाई जाएगा एंड रीसेट पिन एक्टिवेट होगी. जब रीसेट पिन एक्टिवेट होगी वो सारे पिन का स्टेटस रीसेट कर देगी एंड आवर कोड एग्जीक्यूशन विल स्टार्ट फ्रॉम the beginning. Okay, this is what reset pin is. Then port 3 में is a multi-purpose port. It is general purpose input output bi-directional internally pulled up port, as well as it is general. It is a multi-purpose port. Means it has other functions as well, like RXT, TXT. Means serial reception and serial transmission. Interrupt 0, interrupt 1 means we have external interrupts. These two external interrupt pins. Then T0, T1. T0 से हम हमारे प्लस क्लॉक साइकिल है इंटरनली जो ऑसिलेटर जनरेट कर रहा है. We can use that for a timer, but if we want external frequency, then this is the pin which will give you that. Okay, then T1 is what? T1 is the counter. Okay, it is counter basically. देन राइट बार एंड रीड बार. जब एक्सटर्नल मेमोरी पर डेटा राइट कर रहे हैं तो तब ये पिन अपने को एक्टिवेट करनी. जब रीड करना है तब ये पिन एक्टिवेट करनी. एक्सटर्नल 2 and external 1 is for crystal circuitry, as I already explained, and ground you know. So is this clear, guys?
Yes, sir.
Okay, cool. So let your friends know that I will share the recording of this session and they have to go through it because this is so important, right? Because last few days we were, already looking at some important topics from basics perspective, but today we actually got into embed. Today we actually got into one controller, right? So ask them to go through it, okay? The recording.
Yes, sir.
Yeah, I will stop the screen sharing now, okay? And now I'm waiting for your doubts, concerns, queries, anything apart from this, anything you have. Actually, my house has
So
was
where
here,
are
so I just switched off my camera earlier. Yeah. So, yeah, tell me, you guys understanding me?
Yes, sir.
yes sir.
Okay. Thank you for confirmation. So I just, why I'm always asking you to be active is because I should know what is level of your understanding. Okay, I should know what you guys are understanding by the sessions. Okay, and I'm trying my 100% so that you understand it well. I'm also trying my best to get the doubts out of your heads. Okay, even if you don't want to ask me here, you can reach out to me on my WhatsApp anytime. I'll be available to answer your queries. Okay. I have
Yes,
seen
sir.
some more assignment key emails. I will check those. Okay. And let you guys know corrections. But yeah, anyways, deadline was over. डेडलाइन के बाद यार तुम लोग पूछोगे कब सबमिट करनी है तो आई विल हैव नो आंसर फॉर दैट. ओके, देन डेडलाइन क्रॉस हो ही गई तो कभी भी कर दो सबमिट, है ना? वो फंडा है मेरा. तो ठीक है, see you guys again on next Friday. Till then, complete whatever is pending work, go through the recordings because this is basics. Next time we will go even deeper into the memory organization and other stuff, and we might start with small programs or codes. Okay, so be prepared. Okay, have a nice weekend. Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Hi, Kunal.